Hello, everyone. Welcome to Growth Stage, where we discuss how digital product companies can increase the value of their business. I'm your host, David Vogelpohl. I support the digital product community as part of my role at FastSpring, and I love to bring the best of the community to you here on Growth Stage. In today's episode, we're going to be talking about tips for adopting agentic engineering. No vibe coding here. And joining us for that conversation is the Chief Product and Technology Officer of FastSpring, Chris Bunk. Chris, welcome to Growth Stage.
Thanks a lot, David. Great to be here.
Awesome. Is this your first episode on Growth Stage? I actually don't recall.
It is, as a matter of fact. And
Nice.
I'm excited to speak with you today.
Excellent. Excellent. I know you've done some other podcasts since you've joined here. But for those watching and listening, what we're going to be talking about today are Chris's thoughts, having spent the last few years diving into the deep end of agentic engineering, and he'll share his thoughts on the difference of agentic development versus engineering. What is the difference there? Where we're at and where we're going with agentic engineering. So if you're wondering how you're going to scale agentic engineering within your own org, or maybe you're kind of just getting started, or maybe you're far along, hopefully you'll get some insights today that'll help you with that journey. So Chris, the first question I have for you is kind of a twist. I normally ask people what was the first thing they bought online, but I want to ask you a slightly different version of this. What was the first AI product you spent your own money on?
That would be when ChatGPT first came out. It was the first time I actually forked over money to OpenAI to be able to go get the Pro plan, I think it was called back then, to be able to go in and essentially get more tokens in the latest models to be able to go build stuff. I had read a bunch of stuff, and I had kind of, at the time, I was a little skeptical that LLMs were going to be anywhere near to where they are today. And that was really the unlock moment for me, where I was like, oh my gosh, if they could do this, I could see where it's going to go, where it's going to evolve. And I was almost a little obsessed at it when it first came out. I was spending, like, my wife's like, what are you doing spending your nuts? And we can't sign this, come on. But it was just fascinating to be able to go in and have it build code. And it was so far worse at it than it is today. It's funny to think back on it. But yeah, that was my first product that I picked up, and well worth the investment.
That's cool. Yeah, I remember buying the Pro plan pretty quickly when playing around with GPT, and it was so cheap. And I'm not sure where it is today, but I remember that it was like the $20 plan. Was there a particular roadblock that got you to spend over the free plan, or was it just, relatively cheap, so like, why not get the Pro plan?
The both the newer model and the amount of tokens were both like constraining factors that required. I'm pretty sure there was a constraint on tokens even back then associated with it. And the other thing too is, pretty quickly after ChatGPT, I pulled the trigger on paid Cursor subscriptions and then Windsurf subscriptions. And these are still the early days when these tools were just hitting and becoming known.
Yeah, that makes a lot of sense. I do remember wanting to get access to the newer models as one of the motivators for me personally. And it's funny you mention this idea of quality improving, and it's improving so fast too. It feels like in the early days, it was making tons and tons and tons of mistakes, and it really wasn't ready for proper development and engineering teams, but it's just been so fast. And so I think it's very interesting to think about where we're at and to get a fresh point of view and kind of these touchstones along the way, just so people kind of get a feel for what's happening and can take advantage of that in their own organizations. So one of the things, at least pre-AI, we talk a lot about is, what is a developer or an engineer, or in some worlds we've called assemblers, people who kind of piece together technologies to make products in like this different level of sophistication. And so now with AI, we have abstracted out some of that, and it kind of changed, I'll use a corporate buzzword, but the paradigm, if you will, of what all this means. But I'm kind of curious, with where we're at now, how do you view the difference between like agentic development versus engineering? And are both vibe coding or neither vibe coding? Like, how do you think of the language there and the terminology?
Sure. So first off, I just want to acknowledge that a lot of these terms are fresh, hot off the presses, not like some formal standards body or dictionary company coming in with precise definitions on them. So I'm going to answer this in terms of how I think about these words, and what they mean as best as I can associated with this, but there's no like official standard associated with it. So with that disclaimer, starting off with, when I hear people say agentic development, it's kind of like the narrower focus on when it actually comes time to write code against, something you need to go build. It's that narrow portion of the life cycle where you're like using agents to be able to go build code associated with it. Things have evolved a bit, and I kind of almost think of them in terms of levels of maturity of approaches to that. But there was like the early days where you have auto completion, with Copilot was like the first one to come out with that kind of stuff. And then you had the cursors, the windsurfs, there's a bunch of other tools in that class. And they were like where you had your classic IDE set up, but you had a window that could open up on the side. You could talk to it and it would go in and, crawl across your code base and like fully change files. But then you could also, depending on what mode it's in, like tab through the suggestions. So we're still very looking at every line of code, hands-on, building that out accordingly. When I think about agentic engineering, as opposed to development, I suppose that would mean a more broader viewpoint. I would say a more comprehensive look at the software development lifecycle. There's even a term that gets kicked around that I like called the agentic development lifecycle. And I think that kind of gives a nod to the classic software development lifecycle. You might want a different one in parallel for agentic development, or at least it's evolved and changed quite a bit. But you can use agents and agentic development for everything from ideation, product discovery, and all the facets of product discovery, of course, the actual development, code reviews associated with it, verification and validation, like really the whole life cycle, every single thing that we traditionally do to be able to go build product in a product engineering team is something that we can go in and think back to first principles. What's the right way to do this with agents basically associated with it? Getting to your third word there, vibe coding. It's funny, I have different feelings on this. And so first off, it's the original Karpathy, I always mispronounce his name, I hope that's it, definition of it when he first coined it. It's basically you have an idea of what you want, you ask for it, you're completely black box in the code, you're not directing architecture, you're basically just saying, hey, go in and give me this feature or make this faster or go in and change this behavior. And you're just telling it, and then you validate with a human in the loop and go, okay, that's not quite what I wanted, or hey, this has a bug in it, go fix the bug. You keep iterating, you do it that way, largely black box. To do vibe coding, you don't need to have a strong engineering kind of sense to it with it. And vibe coding is also like a thing that I consider on the spectrum of how much vibe coding you do or not do associated with it. We could, in this case, consider vibe coding to be pretty far end of the pure end of the vibe coding end of the spectrum, but it's really easy to just introduce additional stuff with vibe coding to mitigate a lot of the downsides associated with it. I will say that vibe coding is not fit for like true enterprise grade products and engineering associated with it. And so, you really need to be deliberate about how you set up your agents, about how you drive architecture and be aware of the architecture, how you drive the kind of product flow and narrative as well too, so that you truly can understand it as one of the practitioners building that kind of stuff out associated with it.
So if I'm not a developer or an engineer, but I'm using agents basically to create software for my own personal use, like custom Chrome extensions or something like that. And so that's maybe more vibe coding, where like it's solving a problem. I'm the human in the loop validating that it's doing the job to be done, but I'm not an expert. And so I'm not going to be able to get it really in a state where it's ready for production and like mass distribution and things like that. And so maybe that's a way. And it's funny because you mentioned human in the loop. And one of the things I've been thinking about recently is that really expert in the loop is where you unlock a lot of value, because obviously the agents can help you move fast, but without the expertise to validate what's happening and to direct and orchestrate it, you're really not producing anything of like super high quality, or at least again, something like production ready, able to distribute to many, many people. What do you think of that idea? Is that maybe the difference between like someone that's doing agentic engineering, kind of orchestrating and organizing the entire process with agents, where they're an expert, versus like me, who's just like the human in the loop?
Sure. So first off, vibe coding is extremely useful and the right approach for a variety of things. One is like coming up, basically prototyping, right? Coming up with what you want. There's no better spec if you're an engineering team to go build something out rigorously, build something out mature, than to go in and take a prototype and say, hey, this is exactly what I want from a functionality perspective. And so I think there's an opening where you don't need to route everything through necessarily a product manager that needs to go do all that stuff for you, to have some engineer go prototype it and get really confident. It's now possible to unlock that far closer to the subject matter expert, the domain expert associated with it. So, for what it's worth here, Fastspring, I highly encourage you, if you want something and you want to go vibe code it, and it's like way better than a spec or an ask, and you have the comfort of having played with it. That's the whole point of prototyping. And it used to be expensive enough to prototype that you didn't do it except for kind of like more important, higher leverage kind of activities. Now it's really cheap. You can do it for anything, even little internal tools. And so the other one is vibe coding when you go in and apply it to internal tooling or things that you just don't need that maturity rigor. You don't need things to have 4 nines of reliability sometimes. It's okay if it breaks or if it has bugs, for internal tooling, especially if you're the builder of it. You've hit a bug, you just go ask it to change it. You hit a snag where it's going down all the time, say, hey, I need the reliability improved. And you can vibe code your way through, the egregious ones, and you can accept those kind of faults associated with it. Typically too, if it doesn't have a high scale and you don't have to worry about the scalability, there's another angle on it that, you can be lax on. So it's definitely something I feel like everybody, regardless of technical capability, should put in as a tool in their toolbox.
Yeah, the internal tooling has definitely been an eye opener. Like, oh, we could do this or we could do that. And then I like your point on the prototyping. I have a friend who had a SaaS idea, technology idea, and she was asking me about vibe coding. And I was like, use it to make a prototype. And then if you like what you see, well, then figure out how you get a developer involved to help you bring it to that next level. But that's a really good point about engineers also being able to do that as part of the process, to help them get their head around the problems that they're solving for faster. So, one of the things that's really interesting to me is this idea of agent swarms. Help me understand what an agent swarm is and why would I even bother with the swarm? Why not just have one agent that has the various skills I need to use?
For sure. So a number of things. For one, it's as if, hey, is it better to just have one engineer to work on it or a lot of engineers to work on it? Typically, more engineers will work on it, but as we know from the Mythical Man month, you can't have 10 engineers have a baby in 1 month. And so basically, coming up with a way to at least have some parallelism there, if smartly done, is really important. So that's like kind of the first and obvious area, but it's maybe not even the most impactful. One of the things you could do when you have multiple agents is you could basically, generally you have a parent agent, like a master agent, like that comes in there and it knows the initial ask and intent. And then it goes and breaks down a bunch of subtasks that need to get done in that master agent. And then it'll go hand off those subtasks to specific specialty agents, right? You could have it be a generic agent, but it's better if you have a specialty agent. What a specialty agent does is it takes what gets passed to it and all the context that's built up there, and it adds some additional context that includes how to do that role very specifically. So you could have a security agent that goes in and anything that gets planned, make sure it gets planned to be really secure according to these standards and looking out for these things. You can build up what you consider that great security agent. You could also have a security audit agent that on anything that gets pushed, gets reviewed accordingly there. And that has specific instructions on how to validate and test those kind of aspects associated with it. So in my stack, I have, I guess it depends on the number of projects, but I often have at least 50 different sub-agent definitions, which really should be thought of as different competencies that exist in there. And I have a master agent that can go in and funnel to it. And the reason that's real important is it keeps the context window cleaner. One of the biggest things that really matters or separates out successful and less than successful agentic engineering, in my opinion, is being really smart about your context window. And just to recap for those listeners that may not be asked the question, what's a context window? It's basically all the additional content you bring to the table when you go in and talk to your LLM. So if you think about it like a ChatGPT experience, which everybody I think at this point has had, it not only has the start and ongoing conversation that gets brought into every other response that it gives you that you build up over time, but it also has memory where it goes in and pulls that stuff in it. when you're talking about like an advanced agentic engineering stack and setup, what you're doing is you have source code that you're searching and pulling in and bringing that into the context window. You have, specs that you're bringing in. You have policies and practices and domain models and all this kind of stuff. And the really good stacks are really efficient at bringing that in. And what's nice about subagents and doing swarms is you can isolate which pieces get which chunks of context, which keeps the context window lower, which means higher quality results as well too. So the parallelization and overall higher specialization and quality of results are the big answer or reasons why.
So churning on these jobs in parallel helps you get the overall project done faster, but also having smaller context windows helps with higher quality products. So like good guardrails, basically, to keep it in there. And hearing you talk about these swarms kind of invokes in me principles around like CI/CD, where you have like a suite of regression tests, where you have linting, where you have all these different kind of quality control mechanisms along the way that are kind of all doing their own job in an automated and standardized way. It feels like agent swarms are a bit of an extension of that. Is that a fair observation?
They're both tools that essentially play hand in hand associated with it. I don't know if I think of it as an extension. Let me say this. When you really want to cruise with agentic engineering and go to the really fast speeds that are possible, you need to rethink where you validate in your overall agentic development lifecycle. And so one of the biggest validation mechanisms that exist in traditional development is basically the PR review, the pull request review. And so you have other engineers go in, actually read the code that gets written and get it changed. Additionally, even in building, you're going in and reading your code, you're writing your code in traditional development that goes in there. And so you're building that. And so very quickly, if you start going fast, you find that's the limiting factor, is actually reading and understanding that code and that kind of stuff with it. To be able to go get to a higher level while still keeping enterprise grade rigor involved, what you need to do is be able to have really robust guardrails set up, and that's where CI/CD comes in. That's more of like a tactical tooling kind of solve for it. But at a high level, what you need to be able to do is you need to have incredibly good test coverage. And so I'm talking like, why not have over 100%, which means like every line of code's checked plus some checked multiple times with different flows and scenarios that go there. So really, really strong test coverage, unit tests, functional tests, integration tests, data tests, fixtures, etc. Fuzzing tests, like literally every kind of testing that exists, you probably want to at least consider putting in there and have it be super robust. Another important guardrail is observability. Going in there and being able to actually see the different actions flowing on your system, the conversion rates of all the different funnel steps, golden signals with like error rates, saturation, traffic patterns, etc., with really good alerting setup around it. So that really good observability and alerting stack becomes way more important. And then the third piece, which is where product management evolves quite a bit in this new model, as I'm seeing, is the specification, is at least what I'm calling it right now. What we're talking about is extremely articulate specification of exactly what the behavior of the system is, both in happy path and edge cases and stuff that exist. Along with like user profiles and all that kind of stuff. There's a lot of rich data that we create and often have in our heads, but sometimes write down as part of product management during product discovery. That's got to get to like a level that's never been seen before. So there's like spec-driven development's getting really popular around that kind of stuff, but it really means just really clear definitions around what's done there. If you have that trifecta of guardrails, that's when you start getting comfortable that your validation level is at or better than it traditionally is, and you're able to stop having to need to validate it with reading every single line of code. You still want to understand the architecture, drive the architecture. You still want to understand the product strategy and the flows and the directions and stuff like that, but you don't need to literally read every line of code associated with it.
So the guardrails are important, of course, and then you kind of talked about how having super extensive testing coverage is, like you said, more important than ever. And I'm assuming it's easier to get better test coverage as well.
It would be insane to invest using traditional approaches to come up with this rigor of test coverage that exists normally, or at least a lot of companies it would be tough to swallow. We kind of be more pragmatic traditionally of, 40, 60, maybe 70, 80% test coverage, cover the happy paths and some of the obvious bad paths, particularly if they introduced issues in production, to have them as regression tests. Once all that kind of stuff is in place, that's where you can really start to have confidence that the system's going to stay on the rails and fulfill what it needs.
So of course we always want like super extensive test coverage, but it sounds like in this case with agentic engineering, because so much of it is abstracted away, is that one of the reasons why it's more important than ever? Is because you're kind of trusting what it's creating in some regard. So therefore you want to make sure you have like super hardcore test coverage.
Yeah, enterprise grade agentic development or engineering, I should say, it really requires having as much or even more confidence that the code behaves exactly how you want to. And so that's why I think those three guardrails, it's almost like the triangle to success in agentic engineering, if you will, but they all interact with each other in ways. Really strong specs becomes really easy to turn stuff into really strong test coverage. Really strong specs, really good to create the observability. The observability is the real-time ground truth of what's happening at any given moment in the system, where the test coverage is, making sure that the fundamental behaviors of the system don't regress or, go astray and what's needed overall with it. And if you see cases where the observability or the test coverage fail, that's where like the spec needs to be better articulated and tightened typically to make sure that that behavior is encompassed within it.
So for agent swarms or agentic engineering in general, how does it work across teams? Like you set up your swarm, but like how do you make that work across a larger engineering organization?
For sure. A lot of engineering organizations that I talk to and see, they kind of like, hey, let's hook everybody up with Claude Code or similar kind of tool or tools. And they say you can do your normal job, just use agents in it. And the reality is to get a high performance stack up, you got to go in and create those sub agent definitions tuned to your stack, tuned to your practices and policies that knows about all this kind of fundamental knowledge that you have, like that might be in a wiki or whatever, like your spec type knowledge associated with it. It's not all in source code. And so setting all that up individually by individual people on the team or different teams, they're going to have essentially some, one, you got to repeat that effort off with everybody, or at least whatever level they go in and build it, which is why it's way better to have a deliberate shared way to be able to go in and empower people to work at these higher levels of agentic engineering, which requires deliberate planning and thought put towards it. Like one example, having a vector store, which is like a data store that allows you to look for similar content based on what you're looking for. And it'll search it could index and search across large bodies of knowledge. Could be your code base, but most tools do that out of the box. But you want to like incorporate in your wiki if it's got all your product documentation and other potential data sources, and it indexes it. It makes it real easy to find it. So a really good stack can go pull that into the context window, the right data that's needed overall. That's what I would say is like the key part of that.
Okay, so that makes sense. And obviously, you don't want a bunch of snowflake configurations out there where people are like doing their own thing. So, like, all this, of course, is happening really, really fast. And I feel like even within the last year, we've kind of gone from like people maybe even being a little embarrassed they're using agentic development to like now it's just a requirement. And like people are getting left behind if they're not adopting it. But to kind of get it more to like the human level here, what are like key things to pay attention to get your team to adopt agentic engineering in a way that allows them to do their best work in a healthy way? Like how do you address the human side of adoption with your engineering team?
There's a bunch of things I think that I've learned or validated, or even some I've invalidated, but one is you have to still keep the responsibility with the human being that the code being pushed out is to the standards that the company expects. Claude ate my homework is not a valid excuse, right? Like at the end of the day, I don't care if Claude wrote your code, that you have to be in there. And that in turn is a forcing function, right? Because, it takes time for people to learn the tools and the new workflows. And so if they're responsible, if a bug goes into production, if something were to bad to happen, like over the years, traditional development, we're used to this. The PR review, you have the initial author and the PR reviewer kind of have a degree of responsibility over what goes into production. And so until a team member has enough confidence with the tools and what they could do, and that they shift their normal verification validation, anchor that they have into a higher level, they're not going to be able to go in there and be able to have confidence with it. That I think is one of the longer tail things as people kind of go in their agentic engineering journey, that you can't rush that fast. There's no just trust me or just go with it type of thing with it. You need them to understand what's happening, what the tools can do, and to have enough confidence in that security layer that exists overall in it. There's a lot of reactions people have when they get into this, particularly if they maybe did stuff early and kind of said, oh, it's not ready for prime time or whatnot, and then woke up, say, after November when the newer Anthropic models that were particularly elite in my mind in terms of efficacy. That's where you started to see really good engineers go, wow, right? Like I had one engineer once say to me, like, man, I'm glad I'm towards the end of my career. I don't know how much is going to last. So sometimes you go into like the doomer kind of mindset. I don't actually subscribe to that. Everybody's going to be a force multiplier or have a force multiplier that they didn't before. And I think it's going to be measured in hundreds of percent or X factors. It's not just like 20, 40% improvements that companies just dabbling in and see right now. And when you have that higher level impact that you could do with it, you're like, we're not a cost center generally in software. We're often a value creator. And I've never been somewhere where we didn't want to build way more than we could, even when I was pretty well at companies that had a lot of funding. I'm a believer that I always pronounce this one wrong too. Devon's paradox or Devon's paradox or Javon's paradox, one of those. Anyways,
some paradox.
Yeah. So it's where basically the cheaper something gets, the more demand there becomes for it, right? And so you might have back in the day when electricity came into the scene going, oh, I got enough for my 6 light bulbs in my house. This is going to be the end. The market, it's going to be hyped. We don't need more electricity. But quickly people found more uses as electricity got cheaper for, hey, I got a dishwasher now. Woohoo. So, there's all this, build up associated with it. I suspect software engineering is going to be largely like that, unless it's actually an organization that does treat software or their software stack as a cost center. Like if there's just a fixed set of stuff they got to do, sure, maybe they don't need to do way more stuff. But even then, I would challenge them to rethink from first principles of what's possible with going way faster and way cheaper.
So making sure they understand they're responsible for the output. So no Claude ate my homework. Reinforcing the need for the expert in the loop. We need your expertise to make this good. And then it's interesting, and I guess like a DV maybe it's the DV paradox, is there's what I always say is there's more ideas than time.
Yes.
And so as we become more efficient, all those ideas that are filling up everybody's backlogs and the even bigger ideas that we don't have time for, we're now going to have more time to be able to address those things. And so maybe we run out of ideas at some point, but at least we don't see line of sight to that probably today, even the efficiencies we're seeing. And at least for a good long time, we're going to need that expert in the loop. So like some non-technical exec like myself can't roll in and like make the next production feature for our platform. That's not going to happen. We're always going to need that engineering expert in the loop.
You could prototype the next killer idea, by the way.
Sure. Yeah, but not ship it to production, right? Yeah. That's cool. So we talk about the future a little bit here, but where do you think all this is going? Like, obviously we're abstracting out a lot of like the kind of grind work in the engineering world. Where do you think this is all going?
You're starting to see it in the very earliest of companies, but as companies go through their agentic journey and get to the spot where they can create product value per head count at like a 5x, 10x really big factor, we're going to start to see certain companies take off. I mean, it's going to be great for user experiences, right? Like they're going to get way more functionality. Things are going to get far more robust, far more healthier, right? That's the whole cost of it going down associated with it. And ideas that didn't make any sense before because of their effort that would be taken and the risks associated with it, you got to keep going back to first principles. But there's going to be this surge of value creation that's going to happen across the space. Some companies are going to be quicker to adopt it. Some are going to be slower. The ones that are going to be quick are probably going to eat the slower companies' lunch. And there'll be new companies that come out of the wildfire ashes, so to speak, that are going to emerge that wouldn't make sense before, or were the same companies that previously went into the startup graveyard because of the costs or complexities of trying out those concepts. Those are all now going to be viable and on the table, and some stuff we've never even thought of.
Unlocking big ideas. I like that view of the future. All right. Well, we covered a bunch of topics here today. So my last question would be, if people only remembered one thing you said today, what do you think that should be?
I think that going on and thinking of your agentic journey that your product engineering team or company might undertake to be able to unlock those value levers, it is focus on the actual value that you could realize on it and understanding it's a journey and that it can't be done overnight. Like, even if you know all the things and know how to go in and operate at a very high level of agentic maturity, it takes time to get a whole team of humans to come along with you and to learn those skills, get comfortable enough, learn the strengths and weaknesses of these new tools, and get adjusted to them to be able to go in and start introducing the value. So treat it as a journey with various stops along the way, with various goals in the way.
I like that observation. Treat it as a journey. And I love how you also focus that last point on the people element of it and kind of bringing all that together to help drive value. Well, this was awesome. Thanks so much for joining us today, Chris.
Well, thanks for having me on. Always fun to talk with you.
Absolutely. If you'd like to learn more about Chris is up to, you can check out fastspring.com. Thanks everyone for joining Growth Stage. Again, I'm your host, David Vogelpohl. I support the digital product community as part of my role here at FastSpring, and I love to bring the best of the community to you here on Growth Stage. Bye, everybody.
Take care.